Okay, now let us discuss the activity. By the way, this is the second part of our lesson in hypothesis testing about population proportion. Okay, so now it, it's your turn to compute for the value of z. Let us do this step by step. Round your answers to nearest hundreds. So I hope you are also answering on your own, or you will also answer on your own. Suppose the hypothesized proportion or the claimed proportion is 0.3, and what we have or what we got is 0.19 as the sample proportion given 50 sample as sample size. So this one is the formula, and now let us recall or let us replace these rectangles by its corresponding value. Okay, let us recall that this one is p hat, and p hat is obviously 0.19. So what do you think will be the value of this? It will be 0.19. And if you got it correctly, that's good. Now, how about this one? Obviously, this one is p sub 0 or the hypothesized proportion. Same goes with this one and this one. Now, I'll give you 5 seconds to think what will be the value of the hypothesized proportion. Can you still remember? Can you see it on the screen? If your answer is zero point 0.3, you are correct. So that will be 0.3, 0.3. We also have 0.3 here. Now, let us recall this one. This one is n. And what will be the value of n? If your answer is 50, that is correct. Okay? So this one is also 50. Now, you have here, now 0.19 minus 0.3. Subtracting these two will give us, do you have any idea? And that will be negative 0.11. Okay? And for this one, 1 minus 0.3, we have here, do you have any idea? 0.7. Okay? So as we input these in our calculator, it will give us negative 1.7. Okay? Let us proceed to the second example. Given the computed z on example 1 and the following level of significance, state the decision. Reject or do not reject the null hypothesis. But first, let us let us clarify, let us state the decision rule for two-tailed test in hypothesis testing about population proportion. We have to reject the null hypothesis if the computed value of z or the absolute value of computed z is greater than our critical value of z. Okay? And if it is less than, if the computed z is less than, or the absolute value of computed z is less than the critical value of z, you're not to reject the null hypothesis. So let us have these two examples. So in the first one, say the z is 1.58 and we are given, this one is given, the alpha, 0.05. And for the second one, we have z as negative 2.85 and we are given alpha as 0.01. Okay? So, given the alpha, 0.05, it tells us that our level of confidence is 95%. And the critical value of z will be 1.96. Okay? If the alpha or level of significance is 0.05, the level of confidence is 95%. And the critical value of z will be 1.96. Okay? So, let us compare the computed z and the critical value of z. 1.58 is obviously less than 1.96, which is the critical value. Therefore, our decision is not to reject the null hypothesis. Okay? For the second one, we have here alpha as 0.01. And 0.01 tells us that the level of confidence is 99%. And our z value will be 2.576. Okay? By the way, this one is a part of t-table. Okay? Now, the computed z is greater than the critical value of z. 2.85 is obviously greater than 2.576. Therefore, our decision is to reject the null hypothesis. Okay? So that will be all for this second part of our video.